Ladies and gentlemen, ever heard of data leakage? Let me remind you of a case back in 2013 where Edward Snowden exposed military secrets of the United States government, leading to heavy criticism for intruding people's privacy. What Snowden did, whether we believe it is irresponsible or courageous, has placed the data leakage issue in limelight. Here, I would like to show you some statistics prepared by the InfoWatch Analytical Center. Based on these statistics, cases of data leakage show a 22% hike in the 2014. Then in 2015, approximately 100 million personal data records were compromised from around 1,500 cases of data leakage. The effects of data leakage can be very destructive to an organization, from losing the company reputation to money worth millions or billions of ringgit. Hence, this leads to the emergence of a data leakage prevention solution. Ladies and gentlemen, I proudly present to you the evolved data leakage prevention solution. A DLP solution typically aims to prevent both unintentional data leakage as well as intentional data theft by the various levels of stakeholders in the company. This DLP is a comprehensive set of content-aware solutions targeting the government and corporate bodies.
For this project, our team is developing 8 detection modules, each targeting different aspects of data flow in the operating system. LAN drive, mobile USB drive, and web drive aims to detect and monitor the file activities such as read, edit, and delete in these 3 respective areas. Drag and drop, as well as copy and paste, detection modules aims to gather and report the metadata and content of files involved in these 2 activities. Image text retrieval module functions to extract text from various formats of image files. Encryption enforces the control on external software, ensuring sensitive content files are encrypted before they are being sent out. And the final module for network layer proxy decrypts and reveals contents of encrypted files. The evolved DLP is the first Malaysian-developed data leakage prevention solution. In collaboration with MOSTI, the Ministry of Science, Technology and Innovation, as well as Cybersecurity Malaysia, the National Security Agency. This solution will be commercialized soon, and we hope that it will achieve a breakthrough in protecting data for all organizations.
Hello everyone, I'm Janice and this is Sichuan. We are software engineering students studying in Taylor University. According to the statistics, there are 7% of children under age of 5 are overweight. If we look into the Malaysia obesity issue, the issue is getting serious and people are concerned about it. Cyber Canteen is a cashless online canteen solution that aims to create sustainable health awareness and the value for the stakeholders. The system aims to propose as a holistic approach to tackle health issues such as obesity with seamless integration into canteen operation using modern web and mobile technology.
We have used Angular 2 and Ionic 2, a progressive web application environment with hybrid technology that allow us to build the solution on cross-platform web and mobile. It is the latest web technological framework used by the industry, which provides secure, scalable, and leverage on cloud technology to create a distributed application. By 2018, 10,000 government schools in Malaysia will be assigned a nutritionist under Health Ministry to combat obesity issues among school children, with the utmost objective to increase the awareness of healthy eating in and outside schools. Therefore, the system that we built not only allows us to learn and apply our computing knowledge, but at the same time solving a real-world problem.
Centuries ago, our ancestors communicated through postal mail. Decades ago, our grandparents made phone calls to communicate among themselves. Nowadays, we have video calls, Skype, and WhatsApp. take a look at the current technologies and imagine what the future has to offer. Welcome to HoloX Imaging Project, where we, a team of 3 computer students, attempt to develop a next-generation communication software. In this project, we explore the possibility of 3D communication through the internet. HoloX Imaging Project is a highly intensive research project where we need to study and understand what our current technology has in dealing with computer vision and what we need to do in order to achieve our objective. Our project consists of 3 main parts. The first part is the input part, where we convert the information gathered from camera feeds into 3D models. In this part, we utilize OpenCV library, an open source computer vision library to process images and videos for 3D informations such as edge detection, depth mapping, object tracking, and others. Second part is the transmission part, where we compress the information to reduce the data amount and encrypt the data for security purposes. We use ZLib library for data compression and Crypto++ library for data encryption. Lastly is the output part, where we receive the data and display the output to devices such as PC, mobile phones, and possibly virtual reality and augmented reality devices. What we have just demonstrated to you is the future technology where we are advancing into a new era. HoloX Imaging Project will be the future. Welcome to the future. Welcome to HoloX.
The whole idea was originated from the paid-forward ideology. Now, before we start the project, I frequently encountered articles or videos about paid-forward, especially in restaurants where people are able to buy food for other people, especially the homeless, through the restaurant itself, be it in a cup of the teh tarik or a slice of pizza. And that's when I think, why don't we make an implementation in a form of a software? And that's when me and my team decided to work on this project, Food Nation. With Food Nation, we aspire to create an automated system which will act as an intermediary platform for different stakeholders in order to eliminate donation boxes completely and let people to easily engage in this act of kindness called paid forward, where they can donate through restaurants for people in need. We separated our system into 2 major modules. The first is the mobile application for donor. The mobile application will allow donors to find affiliated restaurants, and then they can authenticate their donation if they want to track the donation, and then they can track where and when the donation goes to. This will ensure the transparency of the donation process. And next is the web application of the restaurant, which can be implemented very easily by any restaurants since it's accessible through any web browser. This web application will let them to authenticate and keep track of donation that goes through them. They can also generate reports, and they can call transporters to take food they already prepared. For future implementation, we're going to create mobile applications which can be used by transporters to be notified when foods are ready for collection. They can also navigate where to take the food and where to send them, and they can also authenticate regarding the distribution of the foods. We hope with this system, we can help feed more people in need and enable the community to engage in this act of kindness and make our dream of making the world a better place a reality.
Hi everyone, we are the M2s group. Our project title is Modifying NIC2 for Recording Telephony-Based Addressing in DNS. Basically, our company, iTranscend Sendirian Berhad, is currently developing a new concept domain name server, which is called MINE. Unlike the traditional DNS server, MINE associates domain names to telephony addresses, such as fixed line numbers and mobile numbers, rather than IP addresses. As of current, there are no other telephony-based DNS servers like MINE. Hence, there are no available DNS management tool for it as well. Therefore, the core objective of our project is to customize an existing DNS management software named NIC2 and modify it both interface and code-wise to suit the functional requirements of MINE.
For the name server interface, we were to insert 2 additional fields which is labeled as LSP address and MSP address respectively. Moreover, 2 distinct constraint functions were implemented along with the fields to control the user input. For the zone interface, we were to modify the address type selection where 4 new resource records will be added into it. The 4 resource records are LSP, MSP, SMX, and SMF. Again, to control the user input, constraint functions for each selection were implemented as well.
Lastly, we have enforced some security aspects to the modified NIC2 architecture, where we had implemented some firewall rules that can block two types of attacks, which are TCP SYNC flood attack and dictionary attacks. To further strengthen the security aspect, we had also configured the Apache servers in such a way that user can only connect to the modified NIC2 through HTTPS connections.